The majority of the talk is going to be on the Windows Runtime Platform and specifically the touch and gesture and sort of related areas. We will spend a little bit of time talking about our Win32 APIs. So if you're building a non-Metro app, a desktop app, what's available there for you. And there are some APIs that are Win32 that are also in the Metro SDK, and so those can be used from your Metro apps as well. We'll mention those where appropriate. And this talk was originally supposed to be a chalk talk, but we had enough technical content that they wanted to turn it into a technical session. We're going to do a bit of a hybrid format here, so save some questions as we go. We'll have some time at the end to do Q&A, probably save the last 15 minutes, and then we'll wrap up with a couple slides. So what we get out of the talk, hopefully by the end of the talk, you will understand how to take the runtime and how that really harnesses all the underlying goodness of the Windows platform and exposes it to you in ways that you can use from your HTML and XAML apps. Also, we're going to be using a sample that builds directly on top of iCore Window. So if you're a game developer or if you want, if you have a very perf-sensitive application, if you're trying to get as close to the metal in the Metro-style world as possible, the sample that we'll be working with and iCore Window in general are a great place to start for that. So for Windows 8, we did some massive work in our input stack. Historically, the touch input stack grew out of the tablet input stack, and it was a parallel stack to our traditional Win32 keyboard and mouse stack. And for Windows 8, we decided to merge these two. Windows 8 is a touch-first OS, as you guys have seen over the last couple days. And because of that, because of the features we wanted to build in our UX and have available for our apps, we really had to reimagine what our platform would look like and what the input stack that supported it would look like. That re-architecture had a couple central concepts, a couple principles that we were working around. The first of which was we looked at a lot of the code that people wrote in other frameworks and saw that if you wanted to do something simple, even like a button, you end up writing some code for mouse, you end up writing some code for touch. You probably didn't add any code for pen, but you want your button to work with pen. And so we saw an opportunity to simplify these things. We have this concept of pointer, and if you've been to 185 or 503, the HTML or the XAML sort of intro framework talks, they talk about this. And the basic idea here is instead of writing 3 different but very similar bits of code, you can write one section of code to handle pointing input. And it can deal with touch, mouse, and pen in an easy way. And we have a single cohesive API that supports this. One of our other principles was we spent a lot of time on our touch language. We did a lot of user research. We leveraged a lot of things we learned from Win7, from other groups like Surface, Windows Phone, and elsewhere. And we feel really proud about it. And we wanted to have some way to express it in the platform. So our gesture platform is the way that you can reuse the touch language and the 7 gestures that really make up the core of the Windows 8 interactions in your apps and make it feel like it's part of this cohesive system. Our third principle was code for touch, get mouse and pen for free. This is sort of a mouthful, but it builds on top of those other 2 principles, taking the sort of simplification of things with pointer and being able to generate the set of gestures that are in our touch language with any of those 3 inputs, touch, pen, and mouse. The idea here is that hopefully we've simplified things enough for developers that you can think about your app just from a touch perspective, design it from a touch perspective, write your code from a touch perspective, and you'll get good mouse and pen support right off the bat. We'll talk more about that when we get to the pointer section. And finally, performance. Last but certainly not least, when we did this re-architecture, we spent a lot of time on performance. We have an entire team, a sibling team of ours, that is dedicated to touch performance in the system. And the input stack was one of the places they spent a lot of time and a lot of effort. OK, so let's jump into the runtime and talk about what's available there for touch. So the HTML and XAML frameworks provide a lot of goodness for you. It's sort of like the 80 or 90% case. You can build a lot of your sort of core scenarios using these, but sometimes you need to go beyond what the framework provides. If you've been to, I think it's 874, the sort of intro to the runtime talk, there's a good discussion of how the runtime is really intended to extend these frameworks and let you, where you need to, pull bits from the Windows platform and use them to build on top of what you get in these frameworks. So here's a little chart of how touch support breaks down across things. So the rightmost column, the blue on the Windows runtime one, you can use our runtime APIs from any of these frameworks. So they're additive. If you're working in HTML, so our sort of left green column there are DOM pointer events, and they feel very much like the DOM mouse events that you're familiar with. Under the covers derived from the same event class. They have the same properties, source elements, target elements, and they also have a bunch of pointer-specific properties. There are DOM gesture events as well, so the touch language is expressed through these gesture events. And then for targeting, we've baked our targeting algorithms and heuristics into the controls already. So, if you create an input element and you're putting a button or something on your page, under the covers, we've already done the work in the framework to know how to look at things like contact geometry and be aware of other neighboring controls and make really smart targeting decisions for you. XAML is similar, but XAML is a little more towards the runtime side. There are pointer events, very much the same as you get in HTML, but they natively give you back pointer point, which is our runtime class that represents a sort of single packet of pointer data. There are gesture events as well. They're very similar to both the set of gestures that you get through HTML, and then style-wise, they look a lot like the events that come out of the gesture recognizer, our Windows runtime gesture detection component. And again, we've cooked all our targeting goodness directly into the framework. So a XAML button, behaves very similar to an HTML button. Under the covers, it, knows all our heuristics and is plugged into the targeting logic. So iCore Window is interesting. iCore Window is our sort of base primitive windowing element in the runtime. It's, as I was saying before, as close to the metal as you can get in the Metro world. It provides pointer events. It looks a lot like the XAML pointer events. It also, when you receive these events, get a pointer point attached to it. But it has no gesture events built in. If you want gestures, you can use the Windows runtime gesture recognizer. And the expectation when you're working with Core Window is a runtime interface, is that you'll be using other runtime components as well. And none of these frameworks have device APIs. So if you want to find out what kind of pointer devices are attached to a system, maybe you have a game and you need 4 or more touch contacts to enable multiplayer in your game, you could go to the device APIs using the runtime to figure out those sorts of things. Now you do have a lot of control over targeting in Core Window. There's an event, the touch hit testing event, and how you respond to this, and we'll go over a demo of that, lets you control how targeting works. Okay, so let's start with a quick demo, and we will show the sample that we'll be spending some time with today. Okay, so this is our gesture recognizer sample. It's pretty simple. I'm just going to give a quick overview of things you can do here. You can grab tiles and manipulate them, as you'd expect. We can manipulate the background as well. So you can change your overall view of the scene. Tapping on tiles cycles through colors. And if you do things like press and hold on them, we give you some information about the current transform matrix applied to each of those tiles. So you can see we've got a translation of 289 in the x direction and 12 in y, and a scale and rotation applied to it as well. And then if you let go, it resets whatever that element was to its original position. So this sample is built on top of iCore Window. It uses our runtime APIs. It has a lot of the touch runtime APIs built into it. It uses pointer point, it uses gesture recognizer, it uses our pointer device APIs. And it's also built using C++ projection, sort of a modern C++, which makes it very easy to consume the runtime APIs. So we'll come back to that. Okay, so if you want to build something like that, where do you start? Well, the first thing you need to do is you need to get your raw data. You need to get your touch data somehow. And the way we do that is with pointer point. Pointer point really represents a single packet from some pointer device worth of information. It's some update about X and Y, or a change in pressure or contact geometry, things like that. As I was saying before, pointer brings together all the different pointing devices. So touch, mouse, pen, possibly in the future other pointing devices. Pointer point is also the core input that we feed to gesture recognition. So if you want to use gesture recognizers, pointer point is the raw input that gets fed in there. One of the things that Pointer supports is this principle around code for touch and get mouse and pen for free. The goal here, as I was saying before, is to avoid having to write 2 or 3 copies of code that ends up being very similar. We'll show some pointer code in a little bit, and hopefully you'll see there that there's no examples of places where we're checking the type of the pointer and doing different things on it. Our code is really pretty simple. We take some pointer events, we hand them off to gesture recognition fires gestures for us, and there's no distinction about what the underlying input is. Now, if you do want input-specific UX, there's a talk going on the other side of that wall, in fact, about the ink work we've done in Windows 8. And they're building an app that is a good example of where you might make a input-specific distinction. In their inking app, you can ink with the pen, but then touch lets you select the ink or move it around. So that's something that makes sense for that kind of modality, but it's not necessarily the common case. There are also some input-specific properties in Pointer that you can take advantage of if you want to. Touch has things like the contact geometry. So we use this for targeting, but you could use it in your app as well, or you could build different targeting heuristics if it made sense for your app. Pen has things like pressure, tilt. There's a series of pen-specific behaviors and properties. And then all of the Pointer devices support buttons, but they're sort of most useful for mice, right? Mice have the most number of buttons. So if you're looking at button state changes, you can get those as well. So a question for the audience, actually. I've got simplified code from the sample in slides. This is intended to be interactive. Would you rather see the code in Visual Studio in its full glory, or would you rather do slide versions of things? All right, Visual Studio it is. Good answer. Let me find the project. Okay, Visual Studio is loading up here. So let's talk about, will that maximize? Perfect. Okay, so this is our gesture recognizer sample. Like I was saying before, it's in projected C++, so that's what's the story with these fancy little hat operators. I think this has been talked about in some of the talks, so if it hasn't, let me know. But this is a sort of updated version of C++ that makes it really easy to consume Windows runtime primitives. So let's talk about how we handle pointer events. So we've, elsewhere in the sample, set up this handler to be called when a pointer comes down. So onPointerPressed is called. We get a reference to the core window that the event's being generated on and a series of pointer event args. And you can see that we pull out of those event args the current point, and we pull the raw position out of it. So one of the cool things the platform does as well is when we were looking at, I mentioned before we were looking at performance, there's a series of things that contribute to the sort of total time it takes from when your finger physically hits the screen to when you actually see pixels change in the display. There's a certain amount of latency from the digitizer hardware. It takes a while to scan, sense, decide where the contact is, send that info to us. The input stack, which takes a very, very tiny, infinitesimal portion of that overall time. There's however long your app takes to respond to it. There's a message in the queue. It eventually gets turned into an event. Your app does something with it. And then there's the sort of graphics stack portion, right? You push some changes out to DX. Some period of time later, it goes out to the graphics card. The display changes. So our goal for all of that was, I believe, under 100 milliseconds for that section of time. Raw position is the position of the pointer point before prediction is applied to it. To help compensate for the delay from touch hardware, we have a prediction algorithm under the covers that helps for things like really smooth panning. So you can get the point, if you just got the regular position property off pointer point, it would be the point that has all the prediction goodies included, or if you want unpredicted, you can get the raw position. So we're using unpredicted here for the purposes of the sample. We do a little bit of calculation here to figure out, I think this is for our hit testing logic. Now we basically loop through the tiles looking for a tile that matches where that finger came down. If we find one, we will set iObject to the index into our tile array. And just as a quick note on the architecture of this app, we're going to stick, well, we have stuck a gesture recognizer on each tile and on the background. So there's 5 total. If you wanted to, if you have an app that has like 1,000 things that you could interact with, you could dynamically associate gesture recognizers with these things. So when you see a finger down, you could find a free gesture recognizer in some pool and attach it. Set up your gesture recognition configuration, pump data through it, and get your events. And then when you're done interacting with that, you could return the gesture recognizer to the pool. But since we have so few objects, we took a simplistic approach here. So we do our hit testing. If we do find an object, then we take that pointer down information and we call process pointer down on its gesture recognizer. If we didn't find if we didn't hit test against one of the tiles, then it's the background. And in our array of gesture recognizers, the last one is the one for the background. And we just hand it off to the background's gesture recognizer and tell it to process down. And then we re-render. Process down is an interesting event on the gesture recognizer. We'll talk a little bit more about it when we get to gesture recognition. But basically, it does 2 things. One, it tells that gesture recognizer that you care about that pointer ID. And the gesture recognizer will use that, as we'll see later. And it also hands off that data. So it starts gesture detection on that first bit of data. OK. Let's get back to the slides. Perfect. OK. So very, very quick demo here. Oops. So we're talking about Code for Touch and getting mouse and pen for free. If I use my fingers, I can manipulate with these tiles. I can tap on them and cycle through their colors. I can do the same thing with a pen, or if I had a mouse plugged in, I could do it as well. We can even generate rotation with the gesture recognizer. We have this concept of a pivot point. And the pen basically functions as a single touch for all intents and purposes. Additionally, we can generate things like the tap gesture that let us cycle through the colors here. So let's go look at the code and see what we had to do to handle both pen and touch input. OK. All right, so we go back to our pointer pressed event here. And you'll notice that there's absolutely nothing there that distinguishes between pen, touch, and mouse. We take that pointer point. We don't need to inspect it for any type. We just hand it off to gesture recognition, and away we go. Under the covers, the gesture recognizer is actually 3 different gesture recognizers. One that knows how to deal with touch data, one that knows how to deal with pen data, one that knows how to deal with mouse data. And it will generate the appropriate events for those inputs. So from the perspective of the raw data, our life is really simple. We just hand it all off to gesture recognition, and we don't have to do anything different with touch or pen. OK. So pointer point. Pointer point is, again, our sort of base primitive for holding packet data off a pointer device. It has 2 tiers of information that are available to you. As properties on pointer point itself, sort of first-class properties, are all the things that are common to pointer devices and pointer input. So this is things like the position of the pointer, where it is in XY space. It includes things like the device that a reference to the device that generated the pointer data. There are other things like the contact ID, so that you can distinguish different pointers when multiple are in use. We also have a property bag hanging off the pointer, and this is where all the sort of more advanced properties sit. And this includes things like pressure, tilt in XY, azimuth for pen, contact geometry, a number of other things. Another nice thing about the properties in that property bag is that we have attached sort of smart defaults to these. So let's say you were building a drawing app and you wanted to take advantage of pressure. You know, you've cooked up your drawing app and it just looks at the XY position and sets some pixels in like a canvas in HTML or something like that. If you wanted to use pressure now to maybe change the transparency or the size of your brush or something along those lines, you could do that. And in a lot of frameworks, you'd do something like check and see if the device supports pressure, and then if it does, get the pressure value, and then adjust your brush and the transparency and whatever else. There are, in the property bag, when you retrieve pressure, if the device supports pressure, we'll fill in the appropriate value for you, but if it does not support pressure, then we'll default to a medium value. So you can now write code that just takes advantage of the pressure property, and regardless of whether or not it's supported on that input type, you will get some reasonable value. Now, you may be thinking to yourself, well, I don't like 50% for pressure. That doesn't make sense in my app. I want 100%. You can do that as well. So we also let you get down to the raw HID packet under the covers that the system had that is backing up that pointer point, and you can both set values in there and you can take a look at them. So if in your app you wanted to determine whether in fact there was pressure supported on the pen device, you could go to the packet and see if there was in fact pressure value there, and if there is, then you can use it. Alternatively, you can set your own default, whatever it makes sense. This also lets you do some cool things, like let's say you're writing an app and it's deploying on some custom hardware. Like maybe you're building an app that sits on Surface hardware, and you want to get at tagged objects and the tag data that's there. That tag data is exposed as a HID property. It's not something that we recognize as a common property, so there won't be a sort of friendly accessor for it in the property bag, but you can go to the raw HID usage if you know what it is and pull it out of there. So if you have custom hardware or you're using custom vendor usages in HID for something, you can get to that data as well through pointer point. So here's a quick example of this. This isn't actually backed up by a real sample, but this is some simple example code here. So if we had a similar pointer pressed event, you can see in the pointer has usage, we can check for the pressure usage on that point. So has usage points at a usage page, so 0xD is the usage page for digitizers, and 0x30 is the usage for pressure, and so we can check whether or not pressure is in that point. And we could do something like change our default if we wanted. You can also go and get the raw usage value. So here, 06 is the usage page for custom vendor-defined stuff, and we're just pulling the first usage off it, and who knows, maybe it's a Surface tag or whatever that is for some custom hardware that you're interested in. Okay, let's do another demo. Gesture recognition. So we showed some of the gestures that the app supports. Again, we can do things like manipulate tiles. If I put this thing down, I can interact. Since we have independent gesture recognizers for all of these things, I can interact with as many of them as I can get fingers on. And if I had somebody else up here, we could rotate and resize a number of these things. Additionally, you can tap on these tiles to cycle through them. The gesture detection is all independent. I can tap on them as fast as I can and cycle through all the colors there. Again, works with all of our inputs. And if I press and hold on them, I get information about the transforms attached to all of them and can reset them. And the same thing with the background. If I press and hold on the background, we get some information and can reset that as well. So let's talk about Gesture Recognizer. Gesture Recognizer is our componentized gesture detection API. You feed it with pointer points. The model here is really all apps get the raw data. And then you have your choice to, however you want, take that raw data and feed it to one gesture recognition component, feed it to as many as you have interactable objects. Maybe you'll come up with some interesting ways of combining these. You have one gesture detection component set up for some set of gestures, another one set up for others, and you have some logic that mediates between what each of them returns. We'll talk about an example of that in Windows 8 as well. Gesture Recognizer lets you configure which gestures you're interested in. There's a simple property that you can set the set of gestures you want. And you can also specify some properties for certain gestures. For example, manipulations let you do things like only do manipulations along the x-axis. You can do manipulations along the y-axis or both. You can turn on rails. So some of the gestures have configuration themselves. And one of the other big reasons that you might use Gesture Recognizer is if you want simultaneous gestures. In the HTML framework, for example, the common case there is only a single interaction going on at a time. So it will only generate a single gesture event for all the elements in the element hierarchy. If you, let's say, if you guys saw Satya's keynote yesterday, the very first little tank demo they showed that had multiple tanks and they were kind of firing at each other, if you wanted to be able to interact with both of those tanks and have them shoot at each other, all of that was built on top of a canvas in HTML. And so a canvas is a single element. It's only going to get a single stream of gestures going to it. If you're doing two interactions at once, you really need to plug in gesture recognition behind the scenes to do that simultaneously. So there's other examples of going beyond the frameworks here. There are some gestures that are only accessible through Gesture Recognizer. If you've seen that slide that talks about the 7 gestures that make up our touch language, one of them was swipe to select. Internally, we call that cross slide because in the places it's used, if you go one direction, you get manipulations and panning. If you go the other direction, you get the cross slide gesture, which lets you select and also rearrange. If you want to use that, it's not exposed through the frameworks natively, but it is exposed through Gesture Recognizer. So maybe you're building something like a list view or some control that's pannable in 1D, but you also want either selection or rearrange or both behaviors. Then you'd use cross slide. There are some configurations that are only accessible through Gesture Recognizer. Rails, for example, can be turned on through Gesture Recognizer, but there aren't ways to turn that on in HTML or XAML. If you want to use multiple gesture recognizers together, you also need to do that with the runtime. So I'll show you an example of that in the system. I need to switch which side. I'll do it off the tablet, actually. That'll be the easiest. So our start menu, right? Our start menu has 1D panning here. And it also has zooming for semantic zoom. But then you can also do things like that cross-slide gesture we were talking about, swipe to select, where you can do these short swipes and select things, but if you drag them far enough, they rearrange. This is actually built on top of 2 separate gesture recognizers under the covers. There's one gesture recognizer that's looking for this panning and zooming behavior, but there's also one that, if you come down on a tile, is looking for cross slide, and then eventually, if you get far enough in cross slide, 2D panning. And they have some logic that mediates between the output of 2 of these things. They decide whether you're more likely panning the entire start screen or whether you're interacting with a tile. So if you want to build something like that feeds the same data to multiple gesture recognizers and then has some logic that builds off it, you would use our runtime components for that. We talked about using multiple gestures within a canvas. If that was something you wanted to do, Gesture Recognizer is your friend there. And then finally, if you're building on top of Core Window, again, Core Windows are sort of lowest level windowing primitive in the runtime. You're going to use other runtime APIs, and there are no gesture events directly on Core Window. So you would use Gesture Recognizer there if you want gestures on top of Core Window. OK, so back to Visual Studio. All right, let's open drawing object. And in the attach method, we do a couple things here. First of all, we set up gesture settings. This is a property off our gesture recognizer. And we're just ORing in all the gestures that we want to detect. So we detect tap, we detect hold with mouse, which I'll talk about in a second, right tap, and then a whole slew of manipulation stuff. We want manipulation in both directions. We want to be able to rotate and scale, and we want inertia for all of those things. So we support inertia in each of the components, so you can get inertia in the XY plane, you can get angular momentum for rotation and expansion inertia as well. And then we add all these handlers. So for each of the events that can be fired off the gesture recognizer, we hook up a handler. So for the tapped gesture, we're going to get called back on tapped. Okay. All right, so let's go back to the gesture recognizer sample. And let's find on pointer moved. Okay. We looked at pointer down before. On pointer move is interesting. You can see here that what we're doing is two things of note. First, and this is, I think, off screen, we're calling get intermediate points off the args. We coalesce data behind the scenes for you. So let's say your app's doing a ton of work, it's super busy, and it's only getting around to processing events somewhat slowly. Pointer data flows in very fast. We want every finger on your device to be sending data at least 100 hertz. So if, for the sake of argument, it's taking 20 milliseconds to do some really heavy task in your app, by the next time you get an event, there will have been a series of packets that will have built up. We coalesce all that for you. If we just called get point here, we'd get whatever the most recent data is. But if you call get intermediate points, you will get all the data that was coalesced from the time now back to the last time you received an event. So it's important to hand this all off to gesture detection. There are things that we don't coalesce past, like we won't coalesce past ups and downs, but if there were a series of moves, those moves might have, coming back to the start screen example, it might have been the difference between starting to pan horizontally versus doing a cross slide, depending on what detection or what direction you went. So we go back in time, we get all of that coalesced data, and we hand it off to gesture detection. So the gesture detection has a full picture of what the user was doing. The other interesting thing to note here is we're illustrating one principle. Remember how I said in process down, that tells the gesture recognizer that we want to pay attention to a specific pointer ID? We're just looping through all our gesture recognizers here when we get a move and just handing them all that data. Now, the very first thing the gesture recognizers do in process move is check whether or not it's a pointer ID they care about, and if they don't, they just drop it on the floor. So that's something you can take advantage of if you want. We have to know which pointer IDs gesture recognizer internally wants. So if you pass us data that's uninteresting to us, we'll ignore it. In some apps, maybe it makes sense for you to do that on your own. Maybe you already have a map of pointer IDs and gesture recognizers. I mean, it's possible you're feeding them to multiple gesture recognizers that you're feeding it to. If you do, great. If you don't, feel free to do something like this, which is where you get your moves, just give them to all the gesture recognizers. And if you haven't told us to pay attention to it, we'll ignore it. This prevents needing to re-hit test everything again and moved as well. Okay. And then finally, let's look at handling an event. So let's go over to drawing object and go to the actual on-tapped handler. Okay, so remember when we tap on the tiles, it cycles through the colors? You can see that that's really straightforward here. We're just, for that tile, incrementing its color. If it happens to wrap around, we set it back to the beginning, and then we request a redraw when it's convenient. So really straightforward. We're going to get called in this on-tapped method every time the gesture recognizer sees a tap. Okay. We talked about Code for Touch, Get Mouse and Pen for free. This is supported in gesture recognition too. We have this gesture, the right tap gesture, and this is sort of a meta gesture. it is the collection of all inputs that are morally a right click. So if you take your mouse and right click with it, it'll fire a right tap. If you press and hold with touch, you'll get a right click. If you press and hold with the pen, or if you hold the barrel button and tap with the pen, those four things will all generate right clicks in the system and should be sort of treated similarly. Right tap brings that all together for you. You don't need to know, you don't need to know what the property for the barrel button is and check whether it was a good tap or anything like that. We do all of that logic for you internally in Gesture Recognizer. And let's look at an example of handling that. So back over to Visual Studio. Let's go back to Attach. And you can see that we're listening for right tap as one of the gestures we want. And then on right tapped, which seems sort of grammatically odd, but that's what we named it, we just reinitialize the tile and request a redraw. So reinitializing it both resets it to its original color and bounces back to its original position. The astute observers amongst you, though, have probably noticed that we're also listening for hold. And I just told you that hold, press and hold both with touch and with pen, is one of the things that generates right tap. Hold has more states than right tap, though, which is why we're listening to it in the events here. When hold is a time gesture, so if I put my finger down on a tile, when the time threshold for being a potential hold has expired, we'll generate a hold start event. So you'll get a callback on your hold handler, and one of the arguments for the hold arguments will be that the gesture has started. And then there's one of two things that can happen. You can either move it away, in which you cancel the hold, or you can lift and you successfully complete the hold. Successful completions of hold will generate right tap, but if you care about canceled holds or you want to do something at the start of hold, then we also listen to hold. And so if we go to where we're handling hold, we do some stuff like get that object description. So the string that talked about the translation, the scale, and the rotate matrices applied to it, we build that up and we position it above the hold. So there's things that we do on the beginning of the hold state, for example, here. And if we cancel, then we clear out that text. We don't reset it like we do on right tapped. We also have holding with mouse. By default, mouse already has a good way to do right click. So we don't turn on the hold gesture by default for mouse. If you do want to be able to do that exact same interaction, so if you took a mouse and you just sort of held your left button down over the tile, you can turn on hold detection for the mouse as well with the hold with mouse property. But it's not on by default. Okay, so let's come back quickly to the sample and take a look at the device support again real fast. All right, so if I press and hold on the background, in the upper left-hand corner, and hopefully that's not clipped, well, the top line, hopefully you can see it, says touch internal, and it's telling us what kind of digitizer is generating the input and is used right now. The max contacts are 8 on this digitizer. It supports up to 8 concurrent contact points. And then we get the sort of physical size in basically digitizer pixels of the device and the screen rect. So we're at 1366 by 768 resolution. I can do the same thing with the pen. If I press and hold with the pen on the background. Sorry, too much coffee this morning. It says it's a pen internal digitizer, then max contacts are 1, and you can see the digitizer resolutions different there. So let's show how we can access some of that stuff. Okay, pointer device. There's 3 ways to get at a pointer device. On a pointer point, you have a reference to the device, and you can walk backwards from that. If you have a pointer ID somewhere, maybe you've got your map of pointer IDs and what gesture recognizers you're attaching them to, you can take that pointer ID and call into a static function off pointer device and get the corresponding pointer device that owns that pointer ID. And you can also just get the entire set of pointer devices and enumerate them however you want. The devices have properties on them like the type, the maximum contacts, a lot of the stuff that we were printing out there. One of the other things you can do, sort of mirroring the support on PointerPoint itself, is you can get the list of usages that that device supports. So coming back to our example of if we want to check if the device supports pressure, this is probably the best way to do it. Go back to the device, get the full set of properties that the device supports, and check there. Those properties also include the min and max values for the HID usages so that you can parse the raw data that comes back in HID. If we look at background object real quickly, we can see in get device description, yeah, that guy. We here pull a bunch of properties off. So we check what the type of the device is, we check whether it's integrated, get the contacts, get some of the rectangles, and basically build up a big string that we're going to display in the corner and display that. Okay. If we wanted to get the list of HID usages, we'd do something like this. We can, again, if we have the pointer ID, we can call into get pointer device. With the pointer ID here, we'll get a device back. We can get its supported usages and then loop through those looking for a specific one. Like we're looking for pressure here. We can march through it looking there. Okay, a couple other device goodies quickly. There are three sort of helper APIs. There's touch capabilities, pen capabilities, and mouse capabilities. These give you very quick access to the system's input properties. There's just a property on there on pen, for example, like is a pen present on the system? And for touch, there's one that represents the largest number of touch contacts on any of the touch digitizers that are attached. So if you had a system that had, some touch LCDs and, you also had your Samsung hardware plugged in and one of your LCDs supported like 50 contacts, it would tell you that the system supports 50 contacts. If you want to figure out per device, you can walk through using the device APIs. Using the helpers here is pretty straightforward. Just new up a pen capabilities, check the pen present property. We can new up touch capabilities and pull the contacts off it. If I was building a game and my game's very complicated, I need to support multiplayer, both a pen and at least 8 contacts, this would be some simple logic to help figure out whether we'd enable multiplayer on our start screen. So, targeting. Targeting is awesome. Targeting is one of the really cool features in Windows 8. It uses, behind the scenes, the contact geometry from your finger and a bunch of heuristics and controls that sort of are aware of their position and how much the contact geometry overlaps them, how closely to other controls, to make really smart targeting decisions. If you want to make your own targeting decisions, you can using iCore Windows touch hit testing event. I apologize, I don't have this sample handy, but there's a sample in the SDK called the Shapes Puzzle, and in it, you can see how it handles the on-touch hit testing event. And basically what it does is from the arguments, it can pull out the current best guess at what the target is and the point that we should be reporting. And then in Shapes Puzzle, there's a bunch of logic to sort of iterate through all the shapes and figure out using the geometry, which one is the most likely one to be the user's target. And then based on that logic, we update the event args and set a new target, mark it as handled, and then the system will adjust the point to be on that shape. Oops, sorry, I'll back a slide. Okay, so real quickly, let's talk about the desktop stuff. For desktop developers, our Win32 support mirrors what you get in the runtime platform. And it's really designed to... All right, I'm glad you guys are happy about that. It's really designed to help you build some great touch apps. I did not expect a lot of applause on that slide. WM Pointer. This is our window message that replicates what you get in Pointer Point, or if you're working in like the HTML DOM, the DOM pointer events. Now, a neat thing about the Win32 version of this is not only can you consume the pointer messages in the same sort of one message per contact way, but you can also get the whole frame of contacts. So a frame is, at a given slice in time, the state of all the contacts that that device recognizes. So if I put 5 fingers on the screen, the frame will contain the current state for one section in time of all of those contacts. And as they move, we'll generate new frames that have updates for all of them. This is useful if you're building a framework, if you have some app that can efficiently process in parallel all that data. All of our frameworks, so the XAML, the HTML, Core Window, all of them work in a frame-based manner behind the scenes. So the Win32 version of Pointer, WM Pointer, lets you do that. Interaction contexts are exactly the same as gesture recognizer. Everything you can do with gesture recognizer, you can do with interaction contexts. They're just a Win32 API. Pointer device APIs look a lot like the pointer device APIs with one notable exception, or addition, I should say. You can get PNP notifications for device arrival and departure. And the pointer device APIs are also available in the Metro SDK, so you can use those from your Metro app. If you're building like a C++ app, you can call into the pointer device APIs. Another note here, when we did our re-architecture, we really optimized around all of these scenarios that enable our new UX in Windows 8, that enable our new touch language, and the API surfaces we wanted to support. So pointer, gesture recognizer. We have some, from our perspective now, legacy APIs from Win7, WM Touch and WM Gesture. And so if you're familiar with those, WM Touch is sort of the predecessor to Pointer. Pointer is its bigger, taller, older brother. It's much more powerful. It has a lot of advantages. And WM Gesture is similar to interaction context and gesture recognizer. Now, one of the really nice things with Win8, though, is if you've done any development in Win7, you had to choose between getting raw data or getting gesture detection. And with Win8, everybody gets the raw data, and then you can choose to use gesture detection however you want. So our new model is substantially better. We like it a lot. The old APIs exist for app compat reasons. So obviously, if you have old apps built on top of them, things will still work. But for any new desktop applications, we'd really suggest using the new stuff. I'm happy to give you laundry lists of reasons why they're better afterwards. There's some other goodies in Win32. For touch targeting, there's a WM Touch hit testing event that you can listen to and respond to, much like the on-hit testing event in Core Window. For visual feedback, there's a series of APIs off DWM. They're all called DWM Render Foo. So DWM Render Gesture, DWM Render Tether, etc. And there's set window feedback setting, which lets you control for an H-wind whether you want visual feedback on it or not. For touch injection, so if you like send input, there is inject touch input, which can be helpful for accessibility apps, test frameworks, anything where you need to sort of programmatically inject touch. And additionally, we have this API called ISI, Input Source Identification. You can get to it through, I believe it's get current input message source. So let's say you get a mouse message. You can call that function, and it will return what the type of the underlying input device that generated it was. So maybe you have maybe you've got a bunch of legacy code. It's all based on mouse messages, and you want to determine when you get a mouse message, whether it came from a real mouse device or a touch device, and then maybe do something slightly different when you see touch. You can use input source identification for that. All right, we're running a little low on time, so I'm going to skip past Q&A, go right to the recap, and then we'll take a bunch of questions. So what's the message today? Hopefully everybody's super excited about building Metro-style apps with HTML and XAML. The frameworks provide a lot of great stuff for you. When you want to go beyond the frameworks, though, don't forget about the runtime. The runtime really gives you all the goodness of the Windows platform and exposes it, and it's an easy way that you can additively use from your HTML and XAML apps. If you want to get as close to the metal as possible, build on top of iCore Window. Those APIs are Win Runtime APIs, and you'll natively be using other stuff in the runtime as well. So gesture recognizer, that sort of thing, all go hand in hand with iCore Window. All right, a couple other resources here. 185, which was yesterday, so if you didn't see it, you can watch the video soon. That's our sort of intro to touch in the HTML framework. 503, which was very early this morning, is the XAML version of that same talk. For perf stuff, there is both 162, which is all about building high-performant HTML apps, and 754, which is given by Jason Strayer. It's a talk about how to build games. He uses Pointer in there for getting his touch input. And then there's some general talks. 874 is a just sort of general overview of the runtime. It's good if you're just getting started with the runtime. And then 391 talks a lot about how we built our touch language, how it's expressed in Windows 8, and the general sort of design philosophy of Windows 8. So all those are good talks. A couple other resources, samples. There are the two confusingly named Gesture Recognizer and Gesture Recognizer Sample. We'll try and fix that before we ship this thing. Gesture Recognizer Sample is the one that we talked through today. That's our C++ one that's built on top of Core Window. The one called Gesture Recognizer is a WWA sample that uses SVG and is basically a ball in a maze. You can rotate the maze and sort of bounce the ball through it. And it supports a couple of gestures like tapping on it, press and hold and stuff. Shapes Puzzle is the SDK sample that talks about hit testing. And there's lots of docs available on dev.windows.com. So thank you, guys. I'm happy to take questions here. I'll also be in the expo hall for the rest of the day. And please don't forget to fill out your evaluations. Thanks.